Hello, my name is José Montenegro. I'm going to talk about the interview that we have with Dr. Gaugel in last Friday. Water table, also called the groundwater table, is an upper level of an underground surface in which the soil or rocks are permanently saturated with water. The water table separates the groundwater zone that lies below it from the capillary fringe or zone of aeration that lies above it. The water table fluctuates both with the seasons and from year to year because it is affected by climatic variations and by the amount of precipitation used by vegetation. It also is affected by withdrawing excessive amounts of water from wells or by recharging them artificially. In, re- in, re- in response to gravity, water seeps into the ground and moves downward until the rock is no longer permeable. The surface zone in which all openings of the rock are filled with water is called the zone of saturation. The upper surface of the zone of saturation is called the water table. The zone that exists between the water table and the ground surface is called the zone of aeration. In order to be successful, a well must be drilled into the zone of saturation. The velocity at which water flows underground depends on the permeability of the rock or how large and well connected the openings are. Springs occur where water flows naturally from the rock onto the surface of the land. Springs may seep from places where the water table intersects the land surface. Water may also flow out of the ground along fractures. A water table describes the boundary between water-saturated ground and unsaturated ground. Below the water table, rocks and soil are fully of water. Pockets of water existing below the water table are called aquifers. An area's water table can fluctuate as water seeps downward from the surface. It filters through soil, sediment, and rocks. This water includes precipitation such as rain and snow. Irrigation from crops and other plants may also contribute to a rising water table. This seeping process is called saturation. Sediment or rocks that are full of water are saturated. The water table sits on top of what experts call the zone of saturation or phreatic zone. The area above the water table is called the vadose zone. Unlike the tables you have found in your house, a water table usually is in flat or horizontal. Water tables often, but not always, follow the topography or upward and downward tilts of the land above them. Sometimes a water table runs intersects with the land surface. A spring or an oasis might be the water table intersecting with the surface. A canyon, cliff, or sloping side may expose an underground river or lake sitting at the area's water table. In addition to topography, water tables are influenced by many factors, including geology, weather, ground cover, and land use. Geology is often responsible for how much water filters below the zone of saturation, making the water table easy to measure. Light, porous rocks can hold more water than heavy, dense rocks. An area underlain with pumice, a very light and porous rock, is more likely to hold a fuller aquifer and provide a clearer measurement for a water table. The water table of an area underlain with hard granite or marble may be much more difficult to access. Water tables are also influenced by weather. They will usually be higher in rainy seasons or in the early spring as snow melt filters below the zone of saturation. Ground cover can contribute to an area's water table. The spongy absorbent vegetation in swamps, for instance, are saturated at least part of every year. Water tables in swamps are nearly level or even higher than the surface. Land use can also influence an area's water table. Urban areas often have impervious surfaces, such as parking lots, for instance. Impervious surfaces prevent water from seeping into the ground below. Instead of entering the area zone of saturation, water becomes runoff. The water table dips. Aquifers. Water tables are useful tools for measuring aquifers, saturated areas beneath the water table. Aquifers are used to extract water for people, plants, and every organism living on the surface of the earth. Some water tables are dropping very quickly as people drain aquifers for industry, agriculture, and private use. Scientists call this process aquifer depletion. In regions such as North Africa, people are using the water in aquifers faster than it can be replaced by the rain or snow. People and businesses in North Africa are not using more water than people in other areas, but their aquifers beneath the Sahara Desert are much shallower than aquifers in North America or Australia. Parts of North Africa are experiencing aquifer depletion. Even the enormous aquifers in North America can be threatened with aquifer depletion.